Now we examine some other angle relationships in circles. So in this diagram here, if you have a tangent and a chord intersect a point on a circle, and the point here is A, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So measure of angle 1 is half measure of angle measure of arc AB. So let's say the measure of arc AB is 80 degrees. Then the measure of angle 1 is 40 degrees. Now also in this case, you know that the measure of arc BCA will be 360 minus 80 degrees. Measure of arc is 360 degrees minus 80 degrees, which is 280 degrees, right? So the measure of angle 2 is going to be 1/2 of that, and we divide by 2, that's 140 degrees. So this is how you can find the measure of an angle made by a tangent with a chord where the point of intersection is on the circumference of the circle. Let's look at some angles that are created inside a circle when two chords intersect. The important thing to realize is that these chords are not intersecting at the circle, they are intersecting at any point. So if we look at if we look at angle 1, then the intercepted arc is DC. The angle that is vertical to angle 1 is the one I've just marked. So these two vertical angles are congruent. So the intercepted arc for angle 1 and the angle vertical to it, if you add them together and divide by 2, that gives you the measure of angle 1. And similarly, if you take these arcs AD and BC and you add them together, you get the measure of angle 2, or the angle that is vertical to it. Again, the other angles that you have encountered so far are the central angle, which has its vertex at the center, the inscribed angle, which has its vertex at the circumference. Okay, let's look at the angles that are outside the circle. So in the first diagram, if you have a tangent, the tangent is at point C, and a secant, the secant is AB, or if you just have two secants that intersect outside a circle, then the measure of the angle which is now created outside the circle is the difference between the outer arc, so this is the outer arc, and the inner arc. And these are not technical terms, I'm just saying them so you would understand them. Note the difference between the two diagrams. PQR forms a complete circle, so if you knew the measure of PQR, the measure of PR would be 360 minus the measure of PQR. Just going back up here, when the angles are created inside the circle, you add the two intercepted arc measures and divide by 2. When the angle created is outside the circle, what you do is you subtract the intercepted arcs from the bigger, subtract the smaller, and divide by 2. The third case of an angle formed outside the circle is by two secants that intersect outside, and one more time we subtract from the outer arc the inner arc. Okay. So ignore the colors on the circle, just go by the highlight. The highlighted arc is, the yellow is the bigger one, and from the yellow you subtract the turquoise and divide the answer by 2, and you will get the measure of the angle that is outside the circle. Note again, this is not an inscribed angle. An inscribed angle needs to have its vertex on the circumference. Okay, now you have examples. You're told the line M is tangent to, find x or y. I think this is pretty simple. Again, here you know, write your formula down. Say x is equal to what? And look at the theorems above. Okay, example 3, this is where you're given an angle outside. I am just trying to figure out what these numbers are. Alright, in example 3, the measure of this RTU is 78. And the measure of arc US is 42 degrees, not 420. You know, it can't be 420 anyway. So find the measure of angle X, and angle X is this angle here. Okay. Example 4. Okay, that seems very interesting. There is a little error in this diagram. Let me see if I can fix it. Okay, I had to take a brief pause to redraw that diagram for you. So what the example says is the space shuttle typically orbits at a height of 600 kilometers. Imagine the shuttle in real life. It is going to be flying over, let's say, the Earth. So the question you need to ask yourself is, which distance is 600 kilometers? You're given that PL, which is really the radius of the Earth, is 6970, and if the orbit hovers, the shuttle hovers over the Earth and orbits around it, then it would seem to me that the distance SL is 600 kilometers. So you need to find the measure of arc RQ. So you need to find the measure of this intercepted arc. Hello. Let's try again. And going back to the definition of measure of arc RQ is going to be equal to the measure of the central angle RPQ. So you need to find the measure of angle RPQ. Well, I am hoping that you are seeing two right triangles, and I think you know the two sides of each triangle. So therefore you could find angle RPS or angle SPQ using trigonometry, and then go from there. Okay, good luck with that. I've given you lots of hints. Alrighty, and I see that we do not have answers, so we'll take another little commercial break here. Okay, and here are the answers. And I'm just wondering what 1A and 1B are. They are actually measures, so it really should say x equal to and y equal to, and you know the unit is degrees, so x equals and 1B is y equals. So there we go. So those are the answers. Okay. Alright, you can launch into the problems now.